Hello students, in this video you are going to study about dependencies. This is the second part in the video series for normalization. So if you have not watched the previous video, do watch the previous video and then watch this second part. So let's start with today's lecture. So what is a functional dependency? A functional dependency is a constraint between two sets of attributes from the database. So for a definition, a functional dependency denoted by x determines by y between two sets of attributes x and y that are subsets of the relation R specifies a constraint on the possible tuples that can form a relation state R of R. The constraint is that for any two tuples T1 and T2 in R that have T1 of x equal to T2 of x, they must also have T1 of y equal to T2 of y. So let's see with an example what this definition means. So before we see the example, let's look at some more terms. The abbreviation for functional dependency is FD or F dot D dot. The set of attributes x is called the left hand side of the functional dependency and y is called the right hand side. A functional dependency is a relationship that exists between two attributes. Typically exists between the primary key and non-key attribute within a table. The left side of the functional dependency is also known as a determinant. The right side of the functional dependency is also known as a dependent. So determinant and dependent. Let's take an example and understand what is a functional dependency. So in a class we have a roll number and each roll number is unique. There are no two same roll numbers. So what it means is the roll number used to uniquely identify a student. As you can see here, roll number 12, the student's name is Tom. For roll number 13, the student's name is Dhruv. For roll number 14, the student's name is Saurav. Now, in this database, there are two roll number 15s. Okay. And for like we had discussed before, each roll number uniquely identifies a student. But here, for the same roll number, two names are given. So this cannot happen. Okay, we cannot have roll number 15 with the name as Jimmy as well as roll number 15 with the name as Nelson. Okay, so either the roll numbers 15's name should be Jimmy. Okay, so there should be no Nelson. This should be the Jimmy. So wherever roll number 15 is found in the database, the name of the student should be Jimmy. Or whenever roll number 15 is found, the name of the student should be Nelson. We cannot have different names for the same roll number. So this is the meaning of functional dependency. Okay, given a value of x, you get a value of y. So there's a unique value. Okay, so when we say x determines y, we get a unique value. Okay, even if the value is repeated, so in this case the value say x is repeated, it can be repeated, no problem. You can repeat the value of x, but the value of y should be the same. So you cannot have different values of y for the same x. In other words, you cannot have different values of y for the same x. So this x value is 15. So for this value of x, there should be only one y value. Okay, so it should be either Jimmy, so it should be either Jimmy or it should be Nelson, but it cannot be both. Okay, so this is the meaning of a functional dependency. Let's take some more examples. So how to determine a functional dependency? So given a functional dependency x determines y, how to determine that this is true? Okay, so there are two ways. First way is every row of x is unique. Okay, so if every row of x is unique, you claim that this functional dependency x determines y is correct, is true. You do not need to go and check for the second condition. Okay, but If every row of X is not unique, then you go and check for the second condition. So the second condition states that if T1.x equal to T2.x, then T1.y must be equal to T2.y. So what you mean by that is, like I told you in the previous example, okay, here. So if you are told that there's a functional dependency, roll number determines name. So X is the roll number, okay, and Y is the name. So we are saying roll number determines name, okay, that is the functional dependency. So if it is valid, then there are two ways to check. First, you check for this condition, okay, whether every row of X is unique. So here in this case, roll number is X. So check, is every row of X unique? Yes, every row of X is unique. Therefore, this functional dependency is true, that roll number determines name. Okay, you do not need to go and check for the second condition when this first condition is true. Okay, but suppose we had here one more roll number 15, okay, with say name as, say this was the name, okay. So first you check for this condition. So when you check for this condition, you find that every row of X is not unique now. This is still X and this is Y, okay. So every row of X is still not unique, is not unique. So that time we go and check for the second condition. So what the second condition says is, if T1x is equal to T2x, that is tuple 1x is equal to the tuple 2x. So here you can see this x is equal to this x. Then what it says, T1.y, that is T1.y, Jimmy, should be equal to T2.y. So you can see here, if T1.x is equal to T2.x, then T1.y is equal to T2.y. So since this condition was not true, but this condition is true, therefore we claim that this is a valid functional dependency. Roll number determines name. Okay, I hope you are getting the idea. But suppose we had here the name like this, okay, roll number 15, and say here the name was Tim, okay, name was Tim. So first of all, you are told to check whether this is a functional dependency is valid, okay. X determines Y, or roll number determines name. So first of all, check for this, is every row unique? So when you check, you find that every row is not unique. Here there is a duplicate, okay. So therefore you will go to check the second condition, okay. Always check the first condition. If first condition is valid, do not go to the second condition. But if first condition is not valid, then only go to the second condition. Now you check for this. So here it is 15, T1.x, T2.x is 15. So this condition is true, okay. Therefore you go and check whether this is true. So when you check, T1.y is Jimmy, T2.y is Team. This is not valid. Therefore, this is not a functional dependency now. Okay. So we cannot say now that roll number determines name. This is not a valid functional dependency because this condition here fails. Okay. So I hope you got that idea of how to determine a functional dependency. So let's continue with the examples. Okay, there are some more examples here of how you determine functional dependencies. So the first example we have already seen, given a roll number, okay, you can determine the name. So before we go forward and check out this, please note down these conditions. Okay, you will need these conditions to determine whether it's a functional dependency. So for the first time, you can check whether roll number determines name. Okay, for this example now, this is a new example. So you can check here roll number, every value of X is unique. So therefore, it's a functional dependency. You do not need to check the second condition. Okay. Whereas if you say that name determines roll number, okay, for the second, check whether name determines roll number. So name is X and roll number is Y. Check whether there is every row here is unique. No, there's a duplicate value here. There's a name A here. There's a name A here. Okay, so there's a duplicate. So therefore, check for the second condition. So check whether t1 dot x is equal to t2 dot x. Therefore, t1 dot y should be equal to t2 dot y. But t1 dot y is not equal to t2 dot y. Therefore, what you will say? This is not a functional dependency. This is not valid functional dependency. Okay. Similarly, you can check for the others. Roll number determines marks. So first check, every row of roll number, as we have already discussed, is unique. Okay, therefore this is a functional dependency. So like that, if you take roll number on the left hand side, that is you take roll number is x, then obviously since already we have found out that this every row is unique, any combination of roll number with any other column on the right hand side will give it as a functional dependency. Okay, so you can have roll number determines marks, you can have roll number determines department, you can have roll number determines course. Also, you could have had combinations. You could have said roll number determines name and marks. You could have said roll number determines name, marks, and department. You could have also said roll number determines name, marks, department, course. So any combinations you could have taken for valid functional dependencies. Similarly, if you check for this example, course determines department. Is it a functional dependency? Check. Course. Okay, this is X, course is X, department is Y. Check for the first condition. Is every row of X unique? No, it's not unique. Therefore, check for the second condition. You must get at least one condition that fails to declare that it's not a valid functional dependency. Okay, so when you check for the second condition, only one condition should fail. One tuple you must find. When you compare that it fails, then you can declare that it's not a functional dependency. So after checking for the first condition, it's not unique. Therefore, you go for the second condition. So here you have t1 dot x equal to t2 dot x. So therefore, you expect t1 dot y equal to t2 dot y. But this is not the case. So you have found one place where this is not true. Therefore, you declare that this is not a valid functional dependency. Okay. Same way, if you try to determine whether this is a valid functional dependency, department determines course. Department is X, course is Y. So you can see for the first condition, every row of X should be unique. Okay, it's not unique. So go to check for the second condition. T1 dot x equal to T2 dot x. Okay, so therefore you expect T1 dot y equal to T2 dot y, but that is not the case. Therefore, you will declare that this is not a valid functional dependency. Okay, so I hope you're getting the idea of how to check for functional dependencies. So you can use a combination of attributes on the left hand side, okay, or you can use a combination of attributes on the right hand side, or you could have combination on both the left hand side as well as the right hand side. So the next example, check whether this combination roll number and name, now this combination is X. Okay, roll number and name, this combination, the entire combination is X. So roll number and name, it says is determining the marks is Y. Okay, check for this combination. So check whether any duplicate values are present in X. Is there any duplicate values of X? No. When you check this combination, there is no duplicate values of X. So is it a functional dependency? Yes. By the first condition, since every row of X is unique, we will claim that this is a functional dependency. Okay. What if one of the rows was repeated? Let's say, for example, this row was repeated. Okay, 1 and A say was repeated. So will it be a functional dependency or not? Okay, so when you check for the combination, you would have obviously got that this and this is duplicate. Okay, so every row of X is not unique. This combination of roll number and name is duplicate here. So in that case, you would check that this is t1 dot x, okay, is equal to t2 dot x. So you would expect that t1 dot y is equal to t2 dot y. So here also you would expect the marks to be equal to 78. So if this value is repeated, then this marks also you will expect to be the same. The marks are different, then it would not be a functional dependency. But here 61.x is equal to t2.x, and therefore t1.y is equal to t2.y. Therefore, this would have been a valid functional dependency. Okay, so I hope you are getting the idea. Similarly, check for the next combination, name and marks. Okay, the combination of name and marks. Will it give you the department? Okay, so check for the first condition. Name and marks is now X. So check whether this combination is unique. Is it unique? No. There is this combination which is repeated. A name is A and marks is 78. Okay, so t1.x is equal to t2.x. So therefore, you will expect that t1.y is equal to t2.y. Is it correct? Yes, it is correct. Okay, it is correct. So therefore, this will be an example of a valid functional dependency. Okay, this will be an example of a valid functional dependency. Okay, correct this error. Okay, it's a valid functional dependency. This is valid functional dependency. Okay, for this example, okay, we are only talking with respect to this example. So there are two types of functional dependencies: trivial functional dependency and non-trivial functional dependency. So functional dependency A determines B is called as a trivial functional dependency if B is a subset of A. Okay, so non-trivial functional dependency is when B is not a subset of A. So given a functional dependency A determines B, if B is not a subset of A, then that will be known as a non-trivial functional dependency. So I hope you have understood what are functional dependencies, and thank you for listening.